Question 11. The function f is defined by f of x, which is equal to 10 plus 6x minus x squared for x being real. Then part A, by completing the square, find the range of f. Okay, so our f of x here is going to be equal to, I'm going to write this one in the decreasing powers of x. So we shall have negative x squared, then plus 6x, then plus 10. Now, when we are completing squares, we need to first make sure that the coefficient of x squared here is a positive 1. So I'll divide all through by, we don't divide, we factorize it. So I will factorize that negative 1. That means here we'll have x squared, then minus 6x. I can leave this 10 here. I'm only interested in the terms that have gotten x. Okay. Now, what do we do here? We get the coefficient of x, we divide it by 2. So when we divide this by 2, it will give us negative 3. I put it in brackets with the x, then I pop it out, I put it here. Okay, so I'll put it here, and then I square it, and then plus 10. Why have I done this? Suppose we have x minus a squared. When I expand this one, it is going to give us x squared minus 2ax, then plus a squared. Now I need this side to have the terms that have gotten x. So take this one, this side, we shall have x minus a squared, then minus a squared, which is equal to x squared minus 2ax. Now I want you to look at what is here and here. That is a, okay? But we got this one here, divided it by 2. So minus 2a divided by 2, you get the negative a. Then that negative a is put here and also here. The sign here is always a negative, okay? Is always a minus. Why? Because we have seen that when this one crosses the equal signs, it becomes a what? A minus, okay? So that is that. So that's why I came to this one here. I divided it by 2. I put my negative 3 that I get from there, and then I pop it out here as a square. Okay, now simplified. Negative 1 will multiply with everything here. So we shall have x minus 3, then squared. Negative 1 times negative 9, that will be a positive 9, right? Then plus the 10, meaning we are getting negative x minus 3 squared, then plus 19. Now this is the completed square format. Now, since the coefficient of x squared here is a negative, that means here we are having an N-shaped curve. You see that? That is an N-shaped curve, and the vertex is going to be, equate this one to 0, you get x as a 3, so that will be 3, and then the y coordinate will be that 19, okay? That is an N-shaped curve. Now, the range, we can see that all the values of y here are going to be below this 19, so this is the maximum value of y, the rest are going to be below. You see that? So this simply implies that the range of f is going to be f of x less than or equal to 19. So a function like this has no inverse because it is not a one-to-one, okay? But to make it a one-to-one function, that means they have to choose from here, x being real, either they choose the right of the turning point or the left of the turning point, okay? So that is that. Why? Because here I can have a y value that corresponds to two x coordinates, okay, x1 and x2. So this is many to one value, and yet the function to have an inverse must be a 1-to-1, okay? So that is that. Then lastly, the function g is defined by g of x, which is equal to 4x plus k, for x being real, where k is a constant. And here they are saying that part B, it is given that the graph of y is equal to the g inverse of f of x meets the graph of y is equal to g of x at a single point P. Determine the coordinates of P. Now this is tangency, a single point, one point of intersection, that is tangency. So I'm going to begin for intersection, okay, for intersection, we are going to have g of x, okay, is equal to the g inverse of f of x, okay, because they said that y is equal to g of x. Now, again, y is equal to this one. So just equate these two. As simple as that. All of them are equal to what? To y. Okay. Now, in functions, I can introduce a g here, and then I introduce a g here. And we know that g inverse of g of a function is the same as g of g inverse of the function, which actually gives you x. Why is it like that? I have an x here, then g acts on it, then it gives you the g of x. Okay, what goes into the function is the domain, right? Then what comes out of it is the range. Now, when you bring this one here back, that will be the g inverse, because the g inverse is the one that undoes what a function has done. That means what is here as the range of g is actually the domain of the inverse. And then what comes out of here is the range. You see? So g acted on the x, then g inverse acted on the result. Don't you think that you have come back to the same point? So that's why we have this one here. Okay? Now, I'm going to write this again, and I say this is g of x, which is equal to g inverse of f of x. Therefore, g, in other words, take this one this side. That's what I mean. So g of x then is equal to f of x. Okay? Now, that means go to this one here. Where there is x, put g of x. So we shall have 4, then g of x, then plus k. This one will be equal to the f of x. We were given 10 plus 6x, then minus x squared. So this is 4. What is g of x? Is 4x plus k. Then there is a plus k again here. That is 10 plus 6x minus x squared. This one will give us 16x, then plus 4k plus k. That will be 5k, right? Which is equal to 10, then plus 6x minus x squared. Bring everything this side so that we get a quadratic from here. X squared will now be a positive. Then this one will become a minus. So 16x minus 6x, that one will give us 10x. And then we have this 5k minus the 10. 5k minus 10, which is equal to 0. Okay? Then from there, for a repeated root, okay, then b squared minus 4ac is equal to 0. Okay, remember when you are solving, you use this bulldozer. Some people call it bulldozer, others they call it the quadratic formula. So x is equal to minus b plus or minus to the root of b squared minus 4ac, right? Then out of 2a. Now, this discriminant here in the square root is the one that determines the nature of the turning. I mean, the nature of the roots. So if this one is equal to 0, that means this whole thing is going to vanish. And what you remain with is going to be this one here, which is the repeated root. You see that? I'm supposed to solve this equation as a quadratic, but then it is a single point here that we are getting out. So meaning this one has to be equal to what? 0. So I get my b, which is 10, then minus 4, then our a is 1, and then our c is 5k minus 10, which is going to be equal to 0. Now, when we open this, of course, will be 100, then minus 4 times 5, that will be 20 of k, and then negative 4 times negative 10, that will be positive 40, which is equal to 0. So this one here plus the 100, that will be 140. Right? Then this one is equal to 20k. So when we divide all through by 20, that means our k is going to be 7. Okay? After getting that, they said determine the coordinates of p. So we need to substitute here in this equation here. Okay? So this therefore implies that we shall have x squared, then plus 10 of x, then plus 5 times 7, which is 35, minus 10, this one will give us a 25, right? So we have x squared plus 10x, then plus the 25. So two numbers, when I multiply them, I get 25. But when I add them, I get 10. Of course, that will be 5 and a 5. You see that that is a repeated root. So meaning we shall have x plus 5, then times x plus 5, which is now squared is equal to 0. So our x is going to be equal to negative what? 5. So for x equal to negative 5, then what will be the value of y? Then we can substitute in this one here, y is equal to g of x, okay? So g of x, that one can be 4x plus k. So we have 4, then x, then plus the k, which is what? 7. This is negative 20 plus 7. Isn't this one negative 13? Yes. So that means that our coordinates of P are going to be negative 5 and then negative 13. As simple as that. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.